adding and subtracting fractions by hand today. We are going to perform the operation, and the final answer should be reduced or fully simplified, however you want to think about that. Again, I typically use about 2 colors here, just so you can see like the math that we're actually doing, and then the thing that you actually should write down, you know, something that you could write and do in your head versus what you maybe want to do all the time. Okay, so same size pieces. What do I mean when I say that these are the same size pieces? That makes this easy. The denominators are the same. So you can imagine that what we did was we said, hey, I have a unit cube, a single unit, which you can't see there. Okay, I got a single unit, and what we're going to do is we're going to chop that up into 23 very small pieces.
Please make your way to the auditorium for your pictures, juniors.
So we have 23 little teeny tiny pieces that get chopped up here, and we have 20 out of those 23, and we're going to subtract 1 out of those 23, which means we have what? 19 out of 23. So it's important that our pieces are the same size here. So 19 out of 23. The denominators match. D-E-N-O-M-I-N-A-T-O-R-S. The denominators must match. Very important when we're adding and subtracting fractions. Do they need to match when we multiply and divide? No, they do not, okay? Multiplying and dividing is easy. Adding and subtracting, there's always more we have to do. So we have to make sure when we're adding and subtracting that the denominators match. Okay, now, so I'm not going to model it today. We're just going to go for it. We have a denominator of 4 and we have a denominator of 6, and we need to make them match. And what I'm going to do for now, many of you probably know how to do this, but I'm going to go ahead and talk about the least common multiple. Multiples make things get bigger. We're multiplying. Things are getting larger, okay? What I'm going to do is I'm just going to write a list here of the least common multiple, the LCM. For 4, if we start with 4 and count by 4s, let's see, if I start with 4, what's the next, if I count by 4s, what comes after 4? 8, and then 12, and then 16, and then 20, and then 24, right? And we could go on further if we wanted to. I'm going to do the same thing with the 6. The least common multiple with the 6, let's see, it starts with 6. What comes after 6? 12, 18, and then 24. Yeah, oh, okay, wait. Oh, look at that. Hey, do we have a match? Yeah, okay. So the least common multiple is how we determine what those denominators need to be to make those denominators match. You probably don't remember that, okay? What did you say? Well, wouldn't it be 12? Yes, it would. I'm sorry. Hey, good catch. Yeah, oh, we had a match at 24. Is that wrong to go all the way to 24? No, it's not wrong, but sure, it's bigger, isn't it? 12 is definitely the better least common multiple because it's the lowest. That makes more sense, doesn't it? Okay. I had a really long weekend. I'm really sorry. Okay. So they both go into 12. That is the lowest number that they have in common. Does that make sense to you? Okay. You probably already knew that that was 12, though, but I do like to talk about the least common multiple because that's how we get the lowest common denominator. Okay. Now, to get to 12, what do I have to multiply the first fraction by to make that 4 turn into a 12? 3. Good. So we're going to multiply top and bottom by 3. Why do we have to multiply top and bottom? It does. It stays the same sort of ratio, same proportion. But also, if you think about this, this is like multiplying by 3 over 3. What is 3 over 3? Just 1. Okay? So in effect, we are actually just multiplying by 1. Does that change the fraction at all? No, it doesn't change the fraction. So it's really important. I talk about all these things of the why that we do that, so that you understand by multiplying top and bottom, I haven't changed what I started with, because it's essentially just multiplying by 1. What do I need to multiply the 6 by to get to 12? 2. All right, again, multiplying top and bottom. And I can rewrite now. 3 times 3 is 9. 4 times 3 is 12. We have plus, and then 1 times 2 is 2 over 12. And now the denominator stays the same because it's the size of our little pieces, and 9 plus 2 is 11. And that is done. We cannot reduce that any further. All right, that was a really long way to do that. All right, any questions so far? All right, I'm not going to model it again. We're just going to... again, we could talk about the least common multiple, but what number do 6 and 8 both go into? 24. 24. Again, if you think 6, 12, 18, 24, those are the least common multiples of 6. 8, 16, and 24, and so on and so forth. So again, if you just count by 6 and count by 8, eventually you'll get a number that matches. So what should we multiply the 6 by?
4.
Good, top and bottom. And what should we multiply the 8 by? 3. 1, 2, 3 multiples there. Times by 3, top and bottom. All right, so rewriting my fractions here, their equivalents, we get 5 times 4 is 20 on top, 24 in the denominator. Oh, minus 9 over 24. Now we're subtracting. What happens to the denominator? Stays the same, always. We made it different on purpose. It's going to stay the same. So we have 20 parts and we subtract 9. How many are we left with? 11 parts. Can I reduce this? Nope. All done. Perfect. So these denominators had a least common multiple. What about 9 and 5? Do we need to make a list, or do you know what the low...
45.
45, yeah. These ones, it's just the product of them. But again, you could make a list. So I want to get to 45 here. What do I need to multiply the first fraction by? 5. Does this always work to just like sort of multiply the denominators by each other? It does always work. Is it the most efficient way? No, because you will have to reduce if there's a number lower than their products. We're going to multiply the second fraction by 9 on top and bottom. All right, so what do I get when I rewrite? 7 times 5? 35 over 45 minus 18 over 45. Whoops-a-daisy, I don't know what I'm writing there. 18 over 45. All right, so we have the same size parts now. Our size is 45 pieces per whole. And we have 35, and we want to subtract 18 of those. What is that? 17. Very good. And let's see, does that reduce? No, it does not. Okay. Any questions so far? Pretty easy, yeah? Good? All right, that's good. That's good. That's good. Let's do E and F. And then I'll set you loose. We have 7/10 minus 41 90ths.
So just
9, yeah. If we just multiply the first fraction by 9, that would turn it into 90, which is very nice. All right, what is 7 times 9? 63. 9 times 7 is 63 over 90 minus 41 90ths, because that second fraction is totally fine. And so we have parts, 90 pieces, 90 tiny pieces create the whole, and we want 63 minus 41 of those. What do we get? 22. 22, are we done? No, these are both even numbers, so what do we need to do? divide by 2, divide by 2. What is 22 divided by 2? 11. And what's 90 divided by 2? 45. Very good. And that is reduced. All right. Last one. 2 9ths plus 1/15. What do we need to do there? Let's see. 45. 45 is the thing they have in common. 9 times what gets me 45? 5. So we're going to multiply on by 5, top and bottom. 15 times what gives you 45? 3. Very good. Yes, 15 times 3 is 45. All right, doing a little rewrite here. That's going to be 10 45ths plus 3 45ths gives me 13 45ths. And that is fully reduced. All right. Do you guys have any questions for me? How do you multiply fractions? How do you multiply fractions? Straight across. It's been a minute, yeah? How do you divide fractions? Keep, change, flip. Very good. And what do you need in order to add fractions? Common denominator. Very good. All right, ladies and gentlemen, you have adults math.